Welcome back, students. Today we're going to look at how to solve a system of 3 equations and 3 variables. So it's very similar to solving a system of 2 equations with 2 variables. We'll just have to extend the process just slightly. Alright, so what I'm going to suggest that you do is 1, take your time, because it's very, very, very easy to make a mistake. Just a small little sign here can throw the entire answer off. So take your time and be organized in your work. So I'm going to suggest that you make a table where you can put all of your work. So in this table we're going to have 6 boxes. And in the first box, what you need to do is you need to choose 2 of the equations to work with. Alright, so we have 3 equations. I'm going to go ahead and label those equations. So I'm going to put a 1, a 2, and a 3. Alright, and so what you need to do is you need to pick any 2 of these equations. But be smart about your choice, because we're going to get one of the variables to eliminate. So make a smart choice, and what I mean by that is pick a variable where, looking at the coefficients, it'd be easy to make your coefficients match so then you can cancel them. Alright, so I'm looking at my 3 equations, and I'm looking at I'll look at the x values. Alright, so if I look at the x values, it's not going to be bad because we have a -6, a -2, and a 4. It would not be bad to get those variables, okay, to have the same number out in front, so then we can eliminate, we can cancel them out. Alright, so what I'm going to do is I'm going to look at equation 1, and I'm going to look at equation 2. And then what I'm going to do is I'm going to use equation 1 and I'm going to use equation 2, and what I'm going to eliminate is the x variable. Alright, so trying to eliminate the x variable, when I add these 2 equations together, I need to have the same number in front, but with opposite signs. Alright, so right now I'm just going to leave my equation 1 alone. I'm going to go ahead and write down -6x plus 5y plus 2z equals -11. Alright, but in order to make it so they have the same number out in front with different signs, right now I have a -2, I need that to become a +6. So -2 times what becomes +6? I'm going to take the entire equation 2 and I'm going to multiply by -3. Alright, so I'm going to multiply every term in my second equation by -3. Feel free to use a calculator if needed. So -2 times -3 is +6x. -3 times y would give me -3y. -3 times 4z would give me -12z. And then this will equal -3 times -9 will give me 27. Alright, perfect. So now what we need to do is we need to combine the equations. So I'm going to add them together. And I see that when I do this, my -6x plus 6x cancels out. They eliminate. Why did they eliminate? Because I made it so they had the same number in front with opposite signs. Okay, so they were additive inverses. They canceled out. So then 5y minus 3y would give me 2y. And then 2z minus 12z would give me -10z equals -11 plus 27 would give me +16. Alright, so this equation, I can't solve for a variable because I still have 2 variables. So what I need to do, okay, to solve a system of 2 equations, 2 variables, you need to have 2 equations. So what I need to do is I need to get another equation that only has y and z. Alright, so I need to do this process all over again, picking 2 new equations. So here I did 1 and 2, but now I'm going to use equation 2 and equation 3. Had I done 1 and 3, I could have done that, but I would have had to have a little larger coefficient. But 2 and 3, okay, that's going to be easy for me to get the coefficients to match, to be additive inverses. Alright, so -2 and 4. 2 and 4, the smallest number that they both go into is 4. So I need to change this 2 to become a 4, but I want it to have different signs. So this is a positive 4. I need this to stay negative. So what I need to do is I need to multiply all of equation 2 by 2. And my goal is I once again need to eliminate x. Alright, so I'm going for x, I'm going for x. I'm trying to eliminate the same variable in both of these because I need to have two equations with the same variable. So if I choose to eliminate a different variable here, my two equations won't match with what the variables that they have. Alright, so I'm multiplying all of equation 2 by 2. That's going to give me negative 4x plus 2y plus 8z equals negative 18. And then my third equation, I didn't have to change it at all, so I'll just write it. 4x minus 5y plus 5z equals negative 4. So now I'm ready to combine my equations. Why? Because x has the same number in front, just with opposite signs. And the reason why this is good is because negative 4x plus 4x eliminates, it cancels out. So 2y minus 5y will give me negative 3y. And then 8z plus 5z will give me positive 13z equals negative 18 plus negative 4 will give me negative 22. All right, so now I have a fourth equation and a fifth equation. And notice, because I eliminated x in both of these steps, now my two equations both have y and z in them. So now I'm just solving a system of two equations. So I have right now equation 4 is 2y minus 10z equals 16, and equation 5 is negative 3y plus 13z equals negative 22. I'm going to pick either z or y to eliminate. I think y would be easier. So 2 and 3, the smallest number that they both go into is 6. And we need them to have opposite signs, which they already do, so we don't need to multiply by a negative. So we're going to multiply the first equation by 3. We're going to multiply the second equation all by 2. Alright, so that's going to give me 6y minus 30z is equal to positive 48. And then I have negative 6y plus 26z equals negative 44. Now I'm ready to combine my two equations because the variables have the same number in front with opposite signs. And 6y plus negative 6y cancels out. And the negative 30z plus 26z will give me negative 4z equals 48 plus negative 44, or 48 minus 44, same thing, is equal to 4. Divide both sides by negative 4, and we get z equals negative 1. All right, so there's one of our solutions. We got one of our variables. We had 3 of them. All right, so 2 to go. All right, so next what we're going to do is we're going to plug this back in. But we can't plug it back into one of the original equations because we'd still have 2 variables remaining. So what we need to do is we need to plug it into either 4 or 5. So we're going to now plug z equals negative 1 into either one. I'm going to choose equation 4. Alright, so that means I'm going to have 2y minus 10, but I'm going to replace z, so I'm going to use parentheses with a negative 1, equals 16. So 2y, and then negative 10 times negative 1 is positive 10, equals 16. So then I'll subtract 10 on both sides, and that will give me 2y is equal to 6, and then divide both sides by 2, and I get that y equals 3. Oops. All right, so now I have z, I have y. Now I need to use one of my original equations to then figure out what x is. All right, so you get to pick whichever one you'd like to use. I think I'm going to go with equation 2. So now I'm going to plug z equals negative 1 and y equals 3 into equation 2. All right, so negative 2x plus, replacing y with just 3. and then plus 4 times z, but z is now -1, equals -9. So this will give me -2x plus 3, and then 4 times -1 is -4, so -4 equals -9. Combine like terms, that's going to give me -2x minus 1 is equal to -9. And then I'm going to add 1 to both sides. Cancel out. That will give me -2x is equal to, and then that will give me -8. And then divide both sides by -2, and that will give me x equals +4. All right, so the final thing that you need to do is write these as an ordered triple. All right, so put them in alphabetical order. So variables, we have x, y, and z. So alphabetical order, x, y, z. So I'll put 4 first, comma, 3, comma, -1.